All right, welcome to Skype's Weekly Developer Meeting on this Sunday, the 25th. And we have a first question. And it is from Christopher. Christopher, can you please repeat the question?
Yes. Have you guys discussed anything about privacy issues, about like locations of people's stations, and they may not want to, like say these things appear over their house more than someone else's station. They may not want to be known for that.
Absolutely. Okay. Mm, may I start? Christian, you can go on if you want to. I say the the privacy is a topic on several sides. So we have a privacy issue on the all sky cam because if someone mounts an all sky cam somewhere, they can have a look into the sleeping rooms of other people. So in order not to record whatever is under privacy, shall be masked away. And therefore, Rebecca is doing Rebecca is now working on this mask, and I think she already did it, and it shall now be integrated. Oh no, you expose it as a ROS2 node, and then Mike can take on that. So to take off that masks away the areas within the view of the fisheye that shall not be recorded. Okay. So that's the one thing. That's the one thing towards other people, towards the non-stationeers, let's say. The other way around about a stationeer. So yes, a stationeer is known to us because by becoming a stationeer, you become a supporting member of Sky 360 without any obligation. We give you a station ID so that we can integrate this station then in the total network. And yes, this station shall be referenced with a GPS coordinate, a geo coordinate. But although we do keep this geo coordinate, because we know it where the station is, because there's the GPS sensor, the software knows it, we do not publish this. We would, and this is my proposal, and we discussed this since a year. This is not no new question to us.
Right. You can disclose like the area maybe, but not the
Either
exact
this, but
location.
we need a location because we need for example, the user interface shall also be
Right.
able to see the map where the stations are. So, for example, if three stations see something timely wise in the same time frame, then you could see that on if the triangulation works and so forth. So I do preset now things that are not working now but shall work in the future. But then you will be able to triangulate and see the flying path of whatever object is. To do this, we need the local geolocation exactly. But we do not publish it in the front end. You don't see it in the front end. I would
Right.
say
You keep it
if you,
internal.
yes, exactly.
Oh, you don't need to publish the location of the unit. You want to publish the location of the UAP that was detected.
Oh,
Okay,
okay.
that's one thing. Now, even in DUI, when we display like coordinates and stuff, we can actually reduce the accuracy of it. The accuracy there is not needed, so there will be some ambiguity exactly what
Truncate
where it is,
accuracy,
right?
exactly. Yeah. So
Yeah, yeah.
that's what we have discussed and came up to now. That we said we truncated up to 2 digits after the comma, and
Hmm.
that leaves an accuracy about a mile, roundabout,
Yeah.
roughly.
Okay. That's good.
I mean, still, if you are living in the countryside, if you are a farmer and there's no one else
Yeah, you
sitting
might be
next
the
to
only
you,
person.
you're the only person. Is that might have an issue. That might have, yeah. I have no better
Yeah,
solution to.
another way to do that is just to translate like to a UTM zone. Okay, and maybe add also like the time zone, and that's enough ambiguity of where the station is. Just something to play with.
Time zone is vertical, it goes over the whole
Yeah.
planet. So I'd rather go for
Yeah,
a
I mean the
truncation.
major mission is public
No, but with
awareness,
UTM zone,
or is it
it's a bit better.
Hold on a sec.
sorry.
I do. Go ahead first. Sorry.
No, so time zone gives you the vertical, but UTM zone gives you also the cube.
Okay.
So it's enough.
Yeah, but
Okay.
that's basically the same as geocoordinate. It is a mesh. The time zones are
Yeah, okay, yeah.
no big difference. Christopher, what do you want to say?
Yeah, so the idea is that we're not collaborating with scientists. We're doing something for civilians.
Yeah.
Yes.
I mean,
But we have some issues with the security of the stations as well. Not only the location of the stations. What you have to think about there is that we won't provide any access to the stations from outside. They just send the data in future to a central point, but you can't access the station from outside. Only if you go to the hardware itself and, let's say, put an USB stick in on that. But if it's mounted on your house, you will notice if someone else is doing it. And this gives another level of security. So we won't provide any data that is not necessary to the process. So yeah, the things on that are, we don't want to have an access from outside, so nobody can alter the data.
Yeah.
So there are people that they have the idea, okay, now I'm going to the station and I alter the video like that there is a UFO inside it, and then say, oh, I found a UFO. And we don't want that. So the data should be as pure as possible, and therefore we won't grant any access from outside. The station here, of course, can view, but has no write access in that point.
Yeah.
got it. So then you really have no, as a stationeer, you can't sell your imagery.
No. No. No.
Only
No.
only Sky 360
Yes,
could.
and
I mean,
that's basically the precondition we set our development to. So the software development is under MIT license, and the data creation is under Creative Commons license, meaning it is public domain, anyone can use it under non-commercial aspects.
okay,
When you
I
want
got
to
you.
use it commercially, then we have another discussion.
I see.
And
Okay.
actually, that's the point. When you commercialize things, that means someone owns it and the rest is not owning it. Meaning the stationists become then the owners of the data, sitting on the data and maybe selling the data, and the data becomes a good that is traded and so forth. And actually, we want to have the data because we want to solve an issue and not create a new
Yeah,
market.
I mean, you would imagine if we are capable of capturing an incredible image, that there would be immense interest in that image.
Yeah, definitely. We good point that we talk about it. We have one idea how we can support being a stationer, being. Sorry, Christopher, there's someone talking with you.
Yeah, I'm gonna have to probably cut out, but I have a minute. Sorry.
Oh, you can just mute and unmute when you talk.
Yeah.
Okay. So where was I?
An image that can be captured and sold.
Oh yeah, the licensing stuff. So we want the data basically to be available for everyone because we want scientists to work on that material, or anyone working on that material, even privateers, private people working on that material. But we have to do two things. One is to keep the integrity of the data. So the data shall not be infringible. That's what Christian said, that the path from the creation is from a unique platform that is unique or more or less over the whole planet, the whole network, and creates data that is infringible, that no one can infringe and put some UAPs, as Christian explained, in it, or sell it or whatever, so that when it ends up in the cloud where all the data is aggregated, and then the triangulation can start, because the triangulation is not on the edge. The triangulation has to be in the cloud, because we need the data of several stations collected first before triangulation can happen. But maybe it is different in the future. That's for now, okay? So
Thank you, Richard.
that the path, I'm not not ready yet.
Oh,
So
you
the
said
path of creation, there's a word in English, it's where you know the whole path, where it is created and transferred to where it ends. This, I don't know the English word. I call it the path.
Chain of custody.
Chain of custody, thank you, man. That this is known and secured. But I get the point that stationers are investing their money. Anyone who is becoming a stationer is investing their money and time to get something,
and also placement on their home, or
Yes, and this could be expensive. If you rent the place extra for that, it could be expensive too. So there's an investment,
right.
and we know that, and that's why there shall also be a pro in doing so. Why shall I do that? Yeah, of course. First of all, you should do it for humanity. But if you do not care about humanity so much, maybe you care for yourself, and then there should be at least a little how you say this in English, an asset for you to do it. And the asset could be that you get access to the data before anyone else gets access for a short period of time. So let's say if you are in the exclusive group of stationers, then you have access to the data from the very beginning. When it is there, you have the access in real time, if possible. And people from outside who are not stationers, who are not contributed in any way in development, in this network, in our endeavor, just wanted to use the data, then we can say, no, you have to wait, you have to cool down. This data has to cool down for, let's say, 4 weeks, and then you can work with it. So it gives the stationers 4 weeks time of analyzing, doing, showing, presenting, what have you. This is an idea. How it will turn out in the future, we have to be there. What strategy is best? But for now, we think that's an idea we can set up.
Also, is Sky 360 making any money from procurement of products through affiliate links?
No, we do not make. We do not make.
Okay.
It's not the purpose of Sky 360 making money. And it's good that you asked it on record again. I have to stress that topic. It's not our purpose. I mean, I'm almost 60. I had my life. I made my money and I lost my money again. So I'm done with money. Okay. My only concern is humanity and how we can solve that issue that freaks the people since 70 years. And that's my point of view why I'm here. And I think that, Christian, maybe you can explain your point why you are here. I think it's not far away.
I'm not here for the money, but since I'm an enthusiast, a nerd, and a physician, an astronomer, a computer scientist, my contribution to this is because I think this is a good point to start for us in the new future. And this hasn't to do anything with the money. Our association in Austria is a non-profit organization. And we will have problems with donations that are too huge because we have to spend them on the project, and if things go wrong, we have to pay taxes for it. And so we try to hold that down very much and try to find other ways of how things can be contributed without the use of money. Now, of course, we have to use money for buying. Of course, you have to buy stuff to develop, but the developers do it on their own in a quiet way, and our association can help with that. Let's say the camera I'm just working on, I got from the association financed, but these belong to the association, and when we are done with the development, I will buy my own camera like this. This is not about profit. It's financial profit. It's about developing future technologies, and the UAP subject is a good way to start that.
Tommy, you were shaking hands. You were shaking your head.
Thank you
Yeah.
very much, Christian. I have to run. I'll be back later.
Okay,
Okay,
see
later.
you, Christopher. Bye. Tommy, you were shaking your head.
Yeah, give me that chance to spend the money. I'll buy you all equipment to make you start working.
Yeah, money helps absolutely. So I'm not against money. It's only the philosophy of what we do is without money. Otherwise, it won't work.
I think it's not about the tremendous profit that we have in mind. Money, of course, plays its role because it brings things to order, that we can do things with it. But we are not doing it to get ridiculously rich.
Yeah, agreed.
We're not? What?
We get capable, or we use it to evolve, but not to get ridiculously rich, because you can't take the money to your grave. As someone, as a comedian in Germany once said, your what was it called? Richard, help me out. Sarg.
Sarg?
Ja, ein Sarg, wo Leute drin liegen.
Oh dear. A coffin.
Yeah.
A coffin.
A coffin, of course. A coffin has no drawer, so you
Okay.
can't store anything.
Okay. Yeah.
So,
Yeah.
but I think everything that you gain as knowledge, you can take to the next level.
Yeah.
And if you've survived this being here as a human being on the planet and you dissipate as a consciousness, maybe you can take that knowledge with you.
Yes.
Isn't that a nice idea?
So if we
Yeah,
build
well,
a
I
flying
hope-
saucer one day, we can take all the knowledge with us and build stations on different planets and triangulate them.
Yeah, on that note, coming back to Tommy, I wanted to ask you something about the camera, the QHY. Any idea when you will be able to sell them for the US?
I can now. I thought we decided I wasn't going to buy any until we decided for sure that that was the one we wanted me to buy.
Basically, we are sure with the product. The question is now, we have one supplier here someone who imports it in Europe. But the question is, shall US people also order from Europe and take on that shipping costs? Or is it better to, I don't know, whatever you want?
I can do it. I have been waiting until we decided. I didn't realize that we had gotten to that point. So now that we're there,
we didn't announce it. We decided in the last week that the product is doing what we want of it, and I think today could be the day that we announce it, that we decided that the QHY183C camera will be a product of choice. Then it's good to go with.
I can order them. I mean, as early as tomorrow or tonight, actually, because China wakes up in the middle of the night for Monday, and let them know they've actually already sent me an invoice. So all they were waiting
Sent you
for
an invoice upon what?
For 50 units.
Okay, they invoiced already. All right. Okay.
Yeah. So all they're waiting for is for me to pay it or say something. And we already have the web page built. I showed you that.
And you have to take 50, not less.
I'm going to ask them tonight. I mean, now that I know that somebody else can order one at a time, I'm going to find out what that's about. I mean, see what our options are.
Yeah.
I won't do it. I'll do it like maybe 10 at a time, but I wouldn't do it one at a time.
Yeah.
In the last week, we finished the adapter connecting the Mikey with the camera and fitting it all into the tower. So I think it's a good point to say, yes, we are ready to announce it.
Cool.
Yeah. It's already in the curated list of hardware on the website. But we didn't announce it in a big way. So yes, things come crisscross. Okay, now it is publicly announced the QHY when it receives the one.
Let me ask you something. Did you already put on the Sky 360 website the teleoptics link for people to go and buy?
Yep.
Because if so, you might want to up there and then put our link underneath it for USA, maybe?
Yeah, exactly. That's the idea.
Okay. Yeah, so no problem. I'll
for example,
I'll let you know in the morning.
Your link will be for US people or Canada or the Americas, I don't know. And the other one is the rest of the world for now.
Yeah, just say North America.
For example, yeah. Yeah, we can put it there, no problem. All right.
Yeah, the last week was very busy on having something to show to the end of September because we skipped that deadline we discussed. I think when did we discuss it? In June or so, and I think it's a good point to talk about what we achieved so far.
Yes, go ahead.
Yeah, but
okay. Richard, do you want to share the image of the adapter to just say some few words about it?
Okay, I will. Oh, hold on a sec. Where am I? The adapter is here, and I have to share the screen before I do that. Oh dear, too many windows open here. Share screen. Here, that one. This view, but no, not you, but this one. Okay. Okay.
Okay.
You see the
as you can
okay.
As you can see here, it looks like some kind of flying saucer. That's why we are going to call it internally a flying saucer. If you can see on my camera here, this is the tower with the holes that it's going to be screwed on. I'm going to take my camera off here.
You're showing something on the camera, then I have to go back. Otherwise, I have
no. I think the others can others can see it. If you take that silver ring off, this is how it looks like underneath. Mm-hmm. So we have got some rings in it. And I'm going to show what the camera looks like. Okay, like this. The camera has some kind of flange over here, and yeah, the whole camera looks like this, just a black cylinder, and we are mounting three things together at the same time. The camera is mounted to the adapter. The adapter is mounted to the fisheye lens, and everything is mounted into the tower. We discussed if we are going to build some kind of leveling device in it, so that that we can make sure the fisheye is pointing directly upwards to the sky, to the zenith. But we said, okay, this is very hard to maintain and to fulfill that for people that are not that technically. So we are going to do it in another way. It depends on how you mount the complete enclosure, and then we correct any difference to the zenith by software. And this is what we are working on the last week, and found a very nice solution, because everything fits under the acrylic dome. The acrylic dome and the Mikey lens will be about 1 centimeters away from each other, so the deflections of the acrylic dome won't be that disturbing. I think we won't notice any acrylic dome at all. So yes,
Do
we
you
have some
see?
progress
Do
about
you
that.
see, Christian? Do you see my shared screen?
Yes.
Okay, so Tommy, for example, you see my shared screen?
Yeah.
Yes.
Oh, okay. Okay, so that's what Christian was talking about. So that's the glass dome that sits
Yeah.
over the tower. Inside is the yellow, this white spaceship or saucer, and underneath, mounted on that saucer, is the camera, and mounted on the saucer is the optic, and the saucer carrying the whole camera is then resting on the sleeves, which is part of the tower. So they rest on 3 mounting plates evenly. And what Christian was talking about, I want to make it more clear, because it's a complicated thing, basically. It's very crucial that we know how the fisheye, the all-sky camera, is situated, how it is situated, whether it's horizontally flat sitting or it's slanted in a way. In common, we will always have a slant. I don't think that a stationer will ever be able to create a setup, a platform, a foundation for a station that is 100% flat and equal. And when you set up the station, then that the all-sky cam in the station is then also 100% horizontally aligned. We came to the point where we said that can't be possibly done. I mean, of course, technically speaking, you can do that with a lot of effort to create that. But in common, that would be a rather impossible job to do for any stationeer. So we have to live with this inaccuracy of the all-sky cam not 100% aligned with the horizon. And because it is that way, and we do not want the stationers to go into there and do whatever is needed to balance that out, we do it by software.
Okay, I got a question.
Yeah.
While I fall over here. Does that mean each person's going to have to use a level to make sure they're okay?
No, we want to avoid that. That's
Okay.
why we chose to mount it in a very stiff way and to do it by software.
Yeah.
So there's no need to level it.
Okay.
The only thing that the user there will be an initial process when setting it up, and when the user sees the fisheye view of his hemisphere, he shall then click on known places. For example, the top of a church, or the peak of a mountain, or a building. Something that you can recognize when you go into Google Maps, for example, where you get the geolocation from that particular point that you pointed to. For example, the edge of a house, you can take that from the geolocation from Google Maps, rather precise, and then say that's the geolocation so and so, and the height is so and so, because then it's a 3D known point rather in relation to the globe. And from there we recalculate the camera, where the camera actually is, which we already know from GPS, but then we have an error compensation factor in it. And we also know the orientation. And by knowing the orientation, we know where the zenith is. Yeah, Christian, go ahead.
And if there is no such point, because you have a mathematical horizon, we take the first clear night and do it by the stars. It's as accurate as pinpointing
if you point the right star.
Yes. No, we are going to use plenty of it, because the all-sky camera has not that the resolution to do it like the China method. That's why we're going to use the brightest stars, and it's as good as the China method.
Yeah, I mean,
why not just the north? Why not just use the North Star? Is you have to use more than one?
Because you can't see it on the south on the southern hemisphere.
Yes.
Oh, I hadn't thought of that.
Yeah, it's a big globe.
Yes.
It goes round around.
And it won't be visible if you are around 12 degrees north of the equator. Then you will have difficulties seeing the North Star because it's normally the horizon is too bright for that. So around 12 degrees of the horizon, you can't see anything, the South Pole or the North Pole. But you have plenty of constellations that will do the trick, because if you're in the area around the equator, you can use all the constellations that are on the galactic equator, and this helps a lot. So these calculations are already in place. We have them already. Because they are implemented in the library called astropy.io, and therefore we have all that.
Sweet. Yeah, so that's the setup process. Just build your camera into your enclosure and make some clicks. That should be doable. There was one topic that was discussed yesterday, and it was raised by Mike. Are you there, Mike? Mr. Grunewald?
Yeah, me.
Yeah, you, of course.
Okay.
You raised the topic of how to name the simple tracker from now on.
Oh, okay.
So, at what point did you come so far?
Oh no, I haven't gone anywhere further. I put my little comment in the thing, and then sorry, I've been distracted today with some other stuff. But I think Brad's name was. I'm fine with Brad's name. I just think the only thing I was thinking is that simple tracker just sounds a bit
simple,
boring, really. Yeah, I just thought.
Why did you call it this way, anyways?
It wasn't. I didn't name it initially. Yeah, it was one line of code when I started. So
it simply came to mind.
Yeah. So I just thought maybe we could call it something a little bit more intriguing than simple tracker.
Right.
Yeah, because it's just. Yeah, I just thought it's. I don't know if it's getting more complicated, and obviously it's getting more interesting because I've now got I've integrated other background subtraction library, so it's getting cooler, and I think its name should just be a little bit more cooler than simple tracker. Right. That's the only thing that came to mind, really.
Yeah. So.
So. The new name Brad came up with was Sky Sentinel.
Ghost, you wanted to say something.
Nice.
About Sky Spy.
That sounds
Sky
fancy.
Spy. Oi. Sky Spy. Christopher, what did you say?
Sounds fancy.
I like it.
Yeah, it's like, you know, when you, I mean, I don't know if you guys do this, but if you work on software projects, sometimes they have like code names and that sort of stuff, and it makes you feel like you're doing something groovy, you know, and interesting, and it makes you feel like doing more than you are really, because you're working on a cool project. And I just thought, you know, and that also plugs into imagination and all that sort of stuff, you know, and I just thought, given all that stuff, it would be cool to say I work on something with a cool name versus trying to explain to people what Simple Tracker is, sort of thing,
Yeah.
really. So that was all, you know. That was the only. That was
I had that while I was working on the tracking system. Most tracking systems are called go-to because it's derived from those those amateurs who do not know English and who do not know what's behind the scene. So they say, okay, it's a go-to system. And because that's completely wrong for a tracking system, I said, okay, the others are still going to, while my system is already there. So I called it Be There Telescope Tracking System. And this is why it's called BTTS. And the cool thing is that you can write it as B, T, to the power of 3 and then S. And this explains what Mike just said. Yeah, sometimes you come up with a cool idea of a name and it gets much more of it. Yeah.
Yeah, it's just, I just think it plugs into people's imagination, really, and I think that's just kind of.
So guys, throw in some ideas.
Yeah, exactly.
Throw in some ideas. Tommy, any
Well,
idea?
I mean, you can just. Sorry.
Go ahead, Mike.
Right.
What do you want to say?
No, I was just going to say, you guys don't have to. You don't have to put them on the spot now. They can comment in Hangouts or anywhere really. But it's open to suggestion. You know.
It's your final decision. We're just collecting ideas here for you.
Who, me?
Of course, it's your baby.
Yep.
You have
No,
to
it's all right.
I'll ask
No,
my
it's
wife.
not-
She's good at naming stuff.
Hey, guys, this is important. This is an identification thing. Absolutely, it's important.
Yeah. So it was just that, really. So yeah.
Don't get me wrong, Mike. I'm joking here, but I'm serious too.
No.
I'm serious. It should get a fancy name.
No, agreed. Yeah, no. I completely agree with you. You know,
Let's source it here. So we have 7 other people here. Let's source some names. So we got Sky Spy from Michael. So Michael is the ghost. It's also a Michael.
Then we've got Sky Sentinel from Brad.
Sky Sentinel from Brad, right?
Yeah, I came up with Sky Guardian, but yeah.
Sky Guardian.
Well, how about Sky Eyes?
Sky Eyes.
That would
singular
that
or
would
plural.
much better fit to the all sky cam. And
Well,
in
again, that's,
composition with the PTF.
But it's only one eye.
No, in
singular
composition
or
with the
plural.
PTF, it's 2.
Sky
Yeah,
Eye.
well, that's fine. Again, I'm just throwing things out there. If they work, great.
Yeah,
If they
absolutely.
don't, no big deal. You know?
Guardian.
It's
I'll throw in,
clocks.
What did you
Yeah,
say,
Sky
Christopher?
Guardian's a bit serious, to be fair, but yeah.
Christopher, you wanted to say something.
oh yeah, Tomorrow Tracker.
Once again.
Just something. Or Future Tracker, maybe Tomorrow Tracker or Future Tracker, something like that.
The tomorrow tracker. Okay, I know that. That's a fun word. The tomorrow
have one.
tracker. Mike?
How about Sentinel Scout?
Sentinel Scout. Sentinel
Yeah.
Scout. Sentinel Scout. Is it scouting? I'm questioning. What is it actually doing? Is it guarding? Is it guarding?
No, that's why my name I thought was cool, but it doesn't really explain what it does. and I don't know if that's
How about Skywalk?
Skywarp?
Lab.
Skywatch.
Skywatch. WATCH.
Oh,
I think
They said
Skywatch does exist. Oh, well, it doesn't matter. I mean, it's our software.
that
Skywatch.
work too because you got a whole plethora of telemetry that we're adding to the data. So it's like a laboratory. But I don't know.
Good old
Take it.
Skylab.
I like
Already used, but still good.
I like Sky Sentinel. I think it gets to the point. It's a sentinel. It's something that's scanning the sky.
And
It's something that-
24/7. And it's sentient even.
I think that's the best
Yeah,
option.
and it has logic and algorithms in it, and a Sentinel is a seeker in some kind.
Yeah.
Yeah, I mean, personally, I'm happy with anything other than Simple Tracker, really. so, yes, just something a bit cooler. That's all. Yeah, yeah. So,
Okay. So, yeah, Mike, you heard, you got 7 more ideas.
yeah. Thank you, guys.
Okay. So whenever someone comes up with a fancy idea, I think they can drop you a proposal.
Yeah, no, that's fine. Yeah.
How about Heimdall? The Asgardian. The Asgardian Heimdall. You didn't see Thor?
Heimdall.
Heimdall. Okay.
Heimdall?
Yeah, sorry.
What is Heimdall?
He's the
It's
gatekeeper.
the guardian of the he's the gatekeeper or guardian of the ancient bridge from
Yeah, that's quite cool,
Valhalla
actually.
to the people. This bridge is called Bifrost. And Heimdall, yes, as the guardian of the gate or the bridge, yes.
The
Jesus.
city's called Asgard.
How about
Yeah.
Spotter?
Just Spotter. Spotter is simple. Spotter. Spotter. Because it's spotting, it is. A
Yeah, it's like
UAP
it's like the help of the sniper, right?
But even the Sentinel is doing.
the PTF, the one that is sniping, and so that's the okay, got it.
Yeah, the sniper is always have a spotter next to it. Right?
Sky Spotter.
That's
Yeah.
a good.
Yeah. Yeah. I can see where you're going with that.
It does the classification also.
Yeah.
Yeah. It's food for thought anyway.
Yeah.
Thanks, guys. I appreciate you guys being open to renaming. That's the main thing, really.
Or if you really like the Sentinel, then Sentinel Spotter. That's also good.
There you go.
Yeah.
Yeah.
Spotting Sentinel.
Yeah, Spotting Sentinel.
That sounds like a young sentinel that's got an acne problem. No offense to any, obviously. Yeah.
Yeah, we passed that age.
Yeah, fortunately. Yeah, because they where we live, they are commonly referred to as spots.
Okay. Hey, where you live in the neighborhood, just a quick story. There is David in Scotland, and he made a record from his fish eye and he sent it to me. And we analyzed it, and we came up with no other solution as a drone. A simple drone that you can buy from Home Depot, for example. But it was flying at around midnight. So how can you fly a drone even if it's 10 meters away from you at midnight, you don't see it anymore. How can you fly something like that?
The new ones have highly sensitive cameras now. You can fly at night easily.
Yeah, so in the UK, the police force have got drones specifically developed for the police. That we had, like, I know I can send you the article and stuff, but I know in Wales, because we deal with crazy weather in winter and all that sort of stuff, they've got like drones that have been specifically built to be able to deal with the weather and stuff we have over here. So it's not. So it'll be a lot more complicated. It'll be a lot bigger and a lot more complex than something you can buy off the shelf, sort of thing. But I'm not saying it's that. But what I am saying is it could be a drone at night. I don't see that as a problem, sort of thing. You know.
So
Yeah, you'll see a lot of drones in the sky on the 4th of July. Just look at
It's actually easier to replay a previous flight than actually to fly a drone with even like a night vision. It won't be straightforward.
depends on your camera that's mounted. I mean, if you have that goggle on and control your drone, could work. I mean, you could fly at night. I get that, but
it's
this was
also
just
legal to do so.
I don't know.
But you
Like
need to-
even if you are if you are like a pilot, right, and you're flying at night, you actually don't use your eyes. You use all the
instrument
sensors,
flight. Yeah,
right?
ILS.
Yeah, so it's really like instrumental flights.
Yeah.
So it's
Yeah,
most likely
you're-
like a replay of previous flight than anything else. It's only not
Yeah,
a person. Yeah.
Yeah, you're required to put a beacon on top of your drone that can be seen from a mile and a half.
Exactly.
Yeah.
That's the only FFA.
And now, guys, wait. What I told you is just half of the story. So this drone didn't have any beacon on it. We just could see it because of the street light. It was about 10 meters above the street, hovering and flying from bedroom to bedroom. You got the point?
Yeah.
Okay. There are people in Scotland who fly a drone at night, at midnight, from bedroom to bedroom and filming into. Can you imagine?
That's nasty.
So
I don't think that's.
If
I
they
wouldn't
put
have thought that's a
floodlight on that
Scottish thing.
drone,
It's a Scottish thing.
Jesus.
I wouldn't have thought so. I would have thought you get those sorts of weirdos everywhere. To be fair.
Yeah, probably.
Well, there's always personal anti-aircraft fire.
But
Yeah, the
you
shotgun.
see, Tommy, how important it is
Exactly.
to have that station as a counter measurement against those.
Right.
I just put a link in the Hangouts section, which has a picture of what the Welsh police drones look like.
Okay. Wow. So it looks like
Yeah,
a
you may
submarine.
pick up a lot of people that might not be interested in UAPs, but just like drones over their property. Because there's really no surveillance system for the sky.
No. And that's why I think it's also important to have such a network like Sky 360 so that civilians know what's flying above us, because we do not know yet.
Right.
Anyway, I mean, this is a story about Austria. Austria is a small country, and it's a little bit elongated. And this elongated part is very narrow, let's say 50 kilometers, 100 kilometers, somewhere in between. We do have an air force, but it's ridiculous because when someone flies over our nation, there's no time in the world that we can capture that. And because it is that way, no one cares about flying over Austria. So what I got is information from our Austrian control, that only 50% of overflights are registered. All others just fly over Austria because it's a tiny country, no one cares. And that's why I want to know who is flying there and what object that is that's flying over there. Yeah, okay, it's an Austrian problem, I get that.
Yeah, it's a little bit different here with us, I think. Yeah, so we have. I know we have. I don't know if you know this, but like we have the Royal Air Force on standby that has been since World War II. They on constant standby, 24/7, and if anyone invades or attempts to come into the UK airspace without previous, like without filing a flight plan or any of that sort of stuff, they get scrambled. We have them every now and then. There's something on the news about a big bang, and they've gone through the sound barrier because they've been scrambled because some Russian plane is coming close to somewhere and that sort of stuff. So yeah, so there is some countermeasures here that we have, to be fair, but yeah, I suppose not everyone has that.
Can't stop the drone though.
With a laser.
No, but there is.
Not
I
with
mean,
lasers, please.
yeah, there was that. There is that Lancashire-based company that I try to reach out to that do. What was it? They do Sky Patriot, or that's where my Sky Guardian came from. They've got a Sky Patriot system, which is effectively like drone recognition. So they will do basically what we do, or what we are trying to do, and actually identify the type of drone as well.
Mm.
And they currently being deployed at airports, I think.
Mm. Yeah, Tommy is selling this stuff from Aronia. Right?
Yeah. Oh, okay.
I was wondering, is there an elevation cutoff for that, where they can observe what's coming into a country? I'm curious because I live by the border, and I know there's a lot of activity going on in the skies, and I know that it's being very well monitored. We have a lot of military out here, border patrol, and things such as that. But I was just curious, do any of you know, is there an elevation cutoff, kind of like in that movie Top Gun, where they can't go below, but people can still sneak things in with drones and things like that?
Yes, there's no classification for it's level 6 or something. So if something's flying at 60,000 feet, it doesn't have to file any kind of flight plan.
What if it's flying at...
Yeah. Not many things can fly at 60,000 feet.
Balloons.
I was thinking the reverse, actually. What if it's flying at, 3,000 feet? That kind of thing.
You have to register.
Well, just as a
there's air charts
point of
like what you should fly.
There are lower limits to what air search radars will see and things like that, and that's why you always hear them about we're going in at like 50 feet or something like that. My understanding is U.S. radar capabilities are a little lower than that, but not by much, and so people coming in underneath radar coverage is a real common technique, for lack of a better term, if you're trying to penetrate some airspace wherever. But pretty much everything from there up, at least in the U.S., we'll know about it. And the U.S. is infamous for ignoring things like other countries and things like that. So we tend to cover the globe pretty well from the ground up, and so we know about it. Now, whether we're going to try to intercept it or not, that tends to be a different story, because there's all kinds of things that keep popping up in air search radars that are, what's that? And there's cloud formation or something like that. So again, just a point of information.
There was this, Christian, there was this story, is it 20 years, 30 years ago, where a young German guy jumped in a small airplane in Germany and flew directly no stop, to Moscow and landed on the Red Place.
Remember you mean?
That guy was flying under radar the whole time.
His name was Russ, and he landed on the red on the
Red Place
on the red plane. Yeah.
Red Square.
And he got arrested for that. It's Red Square. I think it's almost 30 years ago, in the middle of the 90s. I think.
But he
92
Russian
or 93.
With a plane.
Yeah, with but it was a light flight plane.
Hang glider with a motor.
No, it was
something like that.
No, it was a
Cessna.
A single engine plane?
No, it wasn't a Cessna.
It was a single engine plane. I swear.
It was like a Cessna 150 or 172, something like that.
A small Piper or something like this.
We can look it up.
Anyhow, this is the thing that drives me a bit, because there's so much flying around. Everyone is using our airspace, and We don't know what it is, who it is, what they're doing there. And you know what I saw? Piggyback flyers. You know what a piggyback flyer is? So one plane flies over and is registered, but the second plane flies in piggyback behind it. And I was asking the Auster control guys why I always see piggyback flyers, and they were smiling and said, "Yeah, the lower one is registered, the upper one not." And they know where our radar stations are, so they always fly in the shadow.
Yeah.
Okay, I've got it here. It was Matthias Rust. He has got a Wikipedia page, and it was on the 28th of May 1987
Ooh.
with the Cessna 172P.
Mm-hmm.
The sports version.
But as far as I can recall, he didn't land. He'd landed once because he needed to pee or something, on a field. But he did not land for refueling, or maybe he landed for refueling. But he did not land on the airport.
Yeah.
Something like this. Yeah. Wild
Yeah,
story.
they may have
Yeah.
detected. Maybe I mean they saw it was slow. They didn't.
You mean
They
they
didn't go
saw him
after it.
coming?
Maybe I mean maybe they just ignored the data. It was just too slow.
Yeah, but maybe he
I
was
don't
scattered.
know.
He was too
Yeah.
small, scattered.
Yeah,
I'm
well, that and
sure
at the
they have
time,
some
if he stayed
excuse.
below about 100 feet, they never know he was there.
Yeah.
Yeah.
So, because at that time, Soviet radar capabilities are not as good as they became. But yeah, as long as he was under about 100 foot, they'd never known he was there.
He didn't do the flight in one piece. He first flew to Faroe Island, then to Keflavik, then to Bergen, then to Helsinki, and non-stop from Helsinki to Moscow.
Wow. Okay. What a round trip.
Yeah, it's
Brave guy.
he started at Hamburg, and he took out the last bench to make room for fuel, and then started his journey.
All right. Yeah.
It's written that he was caught early from the Russian air defense.
Okay. But
The first unit reacted too late. What's
because
next?
he was too fast.
Yeah,
I
kind
mean,
of
they
that,
have,
and
they have
for the
protocols.
other ones, the other air defenses, for them it was too fast, and then just an incoming airplane was reported, and yeah, that's all. So he
Yeah, I
could
mean,
make
there's
it from Finland.
Yeah, there's 9/11. So protocol said that the jets had to go out to the ocean 300 miles off before they took any action inside the United States. That was the protocol.
Yeah, I know. Yeah, in the UK, we almost shot down a plane from Lithuania or something in 2012 or 2013 because it had a radio malfunction, and it was flying towards London, and they couldn't establish contact, so they got approached by two RAF Typhoons, and they've got a. I'll try and find the YouTube video for you guys if you're interested. But yeah, it's a thing. It is a thing, yeah. I'll try and find it and share it.
Yeah, I would say pre 9/11, it's more difficult.
There is an English Wikipedia site about him. I'm going to post it here in our chat.
The plane probably had a nice escort all the way to landing.
No, not really.
Two
The
typhoons flying
articles.
that way.
The article says that he flew beneath 300 meters and just took it 2 or 3 times to 300 meters to avoid icing the wings. And
Yeah.
I'm going to post it here in the chat.
All right. Yeah.
Okay,
That was
there
just
you
a
are.
side note why Sky 360 is important. May I come back to something more technical? We were talking about, Christian, I call it out bluntly. We were talking today about CUDA, yes or no. And we should get a decision on that rather soon. And I think we have a decision for a yes, right? Question is, how much? So how much CUDA cores do we actually need? This question is important because we have to define the hardware that the whole stuff is running on, or several hardware that the software is running on. So what I want to say is we should, somewhere in time, as soon as possible, if you ask me, know how much processor power is needed for several software packages to be used on that board, especially when we talk about CUDA. So I want to know somewhere in time, not today, but I hope for, let's say, in the next 4 weeks, for example, to know which module, which software model is using CUDA cores and how many. Is this an unrealistic question, Christian, Mike, Ido?
I'm sorry?
Whether my question is an unrealistic one.
Yeah, I
No,
think it's quite a
Can you
tough
repeat the
one.
question? Sorry.
Mike, go ahead first.
No, I think it's quite a tough one to answer, because it is so from my point of view, the challenge we have with CUDA is that I was actually watching some YouTube videos about it today, but you need to write software that specifically targets CUDA. So and so OpenCV, the stuff that we use, not everything is able to run on CUDA, and this new background subtraction library doesn't work with CUDA, which is a real shame. And I don't really know what would be entailed into rewriting it for CUDA, sort of thing. So I don't currently have that skill set to be able to do that. So that kind of makes it difficult, or it makes it tricky to try and determine what part CUDA will play in the software, right? So if we look at, so I'm not talking about the machine learning and all those sorts of things. I'm just talking about the stuff that I work on personally. Is that there's only so many operations that will leverage CUDA, and to a point where I don't really know if it's going to benefit us. Like from the simple tracker perspective. And I hate to say that because I think there's a lot of if we could leverage CUDA properly, it would make a lot of things run a lot quicker. But it's trying to find someone that has the skills to be able, to essentially port some of these things so that they are able to be run on CUDA. I've googled this stuff quite a bit, and I can't really find. I managed to find that background subtraction library, but I can't really find. And I will continue looking, but I can't really find CUDA versions of it. Which is a real shame, because I think so where CUDA shines is is if you've got like if you have to do the same operation. So do you know what a for each loop is? So if you're processing a frame and you're having to like process a lot of data in the same way. So you're essentially taking, if you've got a vector and you take point A and point B and you're adding them together to get to point C. So you would have to iterate over the entire array to do that calculation. And that is like a sequential operation. Whereas if to use CUDA, what you would do is you would just go, CUDA's got 10,000 cores or 16,000 cores or whatever it is now. I've got 5,000 of these things that I need to add together. I can do them in parallel as a chunk because I can spread that calculation over all that number of cores. So, and those sorts of, there's a lot of those sorts of operations that have to happen in the sort of stuff that we do. It's just having the skill set to utilize it, and I don't quite know how to approach that. I don't know. Like I've thought about maybe going onto a website like Upwork or Fiverr or any of those sorts of things and see if there are any software devs out there that are CUDA guys that can port stuff from CPU to leverage CUDA, so we can see if we can maybe just pay someone to get. If we can determine that this background subtraction algorithm is the best one, this is the one we want to use, it performs the best out of the lot of them, and then we go, okay, can we contract someone to rewrite this thing so that it leverages CUDA? That was a thought that I had.
Mike, a question.
Think about it this way,
yeah,
right?
Go ahead.
When you want to move to CUDA, you need to parallelize everything, right? Which means you need to look differently at the problem. So instead of working with one frame, you need to parallelize the frame, or break out the single frame to many smaller frames.
Segmentation.
Exactly. Right?
Yes.
And you want to make sure that you have enough overlaps between the frames, right?
The interconnections, yes.
Yeah. Christian knows better than me about that.
So a question to all of you: is it true or am I wrong? If do we have, if we use the simple tracker and use CUDA with several libraries, wouldn't we have then the issue of, for example, first of all, copying the whole buffer from the CPU to the GPU or backwards, and also having the parts of the code running on CPU and parts of the code running on GPU, resulting in asynchronity?
Yes,
so is that an issue?
I'll speak about that. So I shared on the Hangout. I can share it again. There is a NVIDIA SDK specifically designed to execute pipelines like that. Mm-hmm. So it will know how to create, to ensure to reduce the copying from the CPU and the GPU, and minimize even the register. So you can kind of think about like a state that will stay in the CPU, and it will move forward in parallel to what's happening on the GPU in a parallel pipeline.
Mm-hmm. Yeah.
So that SDK has that capabilities, okay? But I will say again, for the first initial versions, we don't need to move to that. We need to make sure end to end we have everything working. I will consider moving to CUDA and optimizing the pipeline as like optimization and like second version of the tracker. When it gets more advanced, we are reducing like a CPU consumption, increasing, moving towards like high performance, right? But what's important here is to understand the inputs and the outputs for the tracker. That's what we are trying to go after now. So once we have that defined and properly working, now we can work on like improving the performance of it.
Yeah, true if you only consider a software perspective, but think about the following. If we now go with version 1 and without CUDA, and then let's say in half a year we make version 2 with CUDA. How shall we deal with the existing stationeers that already bought hardware without CUDA? They now have to throw that away and buy new hardware because we decided to do so?
No, I don't think. I think the hardware is defined. It's there, right? And we most likely can exit what we have today for the Sky 360, okay, and then move towards for more high performance. Now, bear in mind, like the way the market works today, right? With regarding to sensors, there is a lot of requests now to make the sensor like less smarter, right? So even them, they have like a better compute to what will be needed in the future, because they are trying to create very similar to what like a software-defined X is going to be, right? So instead of the sensors becoming smarter, we want the raw data into the compute, and then the compute gets stronger and gets smarter, and that's where the decision will be made. That's where the understanding will be made. Okay. So technically, what I'm saying is, as long as the input and output are defined, we will be able to actually move the entire compute from one unit to another, right? And solve it that way. But we need the understanding of the flows and of the components, the inputs and output of the components.
Yeah. So I think what
so think about it as a software-defined system, right? Right now we can run it on our desktop. We can send like a USB directly to the camera, right? Later on, we can change all of that and really design where each component is going to be deployed and where the computer is going to be, exactly like software-defined.
That's why we chose ROS 2 for handling that streaming.
Exactly. Yeah.
So it doesn't matter what hardware we already have. Of course, if we have much more potential hardware, much more performant hardware, like let's say a graphic card with CUDA cores, lots of them, the algorithm will run much better than on a CPU-based one. But it doesn't matter because the software is handling where it's running.
Yeah, and to really improve on that, what you want is you want to create simulations. So you want the recorded data, you want the raw data, and now you want to start different bunch of algorithms in parallel, see what gets you better result in whatever scenarios. Because again, when you're software defined, you want to say, hey, at night this works better, at day this works better, and you're even changing the entire algorithm. That's where software defined will get you to.
Yes.
Yeah, I think it makes it. I think that I completely agree with you, but I think it makes it really difficult for Richard that's trying to put together essentially a list of hardware that you need to buy to drive a station. You know what I mean? And I don't know if the best thing there is to make it upgradable, like you go with a PC that you can upgrade, sort of thing. But that I think also has its problems. I don't think there's a silver bullet. Is basically
no, but think about it that we are trying to use ROS 2 to abstract ourselves from the hardware, right? So we create like the everything like as a software defined.
Yeah, I just empathize with someone that's trying to put together a list of hardware that's needed to drive the thing, because it's really how do you define? Because I have in the past seen a comment of someone that bought something and it didn't work on it, and he got very upset about the fact that it didn't work, and and all that sort of stuff. So it's it's those sorts of things that you have to deal with as well. It's very difficult to tell people, oh yeah, but you just need to buy better hardware now. And I don't know what the right answer is. Don't get me wrong, but I think that's the problem.
At some point, you have to do a decision on what hardware you're starting. Yeah, I agree to that. But I think it's a little bit too early to determine it. Okay, we've got Pis with 8 GB of RAM, and we've got, in some way, some kind of Jetson board. And some of us may have got a desktop or laptop with a much more capable NVIDIA graphic card. I think this is what, as developers, we have available. And yeah, we could start on trying to run everything on the Pi and the Jetson in combination. But then we can port it to a much more potential hardware. But I don't know if it's a good idea to just say, okay, we skip all the things on the Pi and the Jetson and go for an ATX board with, let's say, a gaming board with a nice graphic card on it. I think this could be a decision much more about the financial stuff. If let's say an i7 board or i9 board is cheaper, or you can get it for, let's say, 1,500 euros, this might be has much more potential than going for a Pi and an HGX board. It depends on what you can get. It will run on both. But I'm not sure.
I think that's all. I think that's all you can do. In all fairness, is at some point I think we're going to have to put together. Once we've got. So I guess there are a couple of things we can do. So I don't think you're going to get resource for free. So basically, the stuff we do takes a lot of computing, and the more compute power you have, the higher the throughput you're going to get.
Yes.
And I don't think you're going to be able to get away from that. So if you have a big budget and you have lots of computing power, you'll be able to run at a higher frame rate than if you have a smaller budget with less computing power. And I genuinely don't know if you're going to. So you can make it cleverer by leveraging stuff like CUDA and all those sorts of things, but I think fundamentally, I don't know if you're going to be able to get away from those constraints. It depends.
So in that regard, again, there will be a lot of optimization that we can do to improve performance on running on the Pi and the NVIDIA. Okay. Right now, I think we are just in the beginning of it. But as I said, like a few weeks back, think about it that we are reducing the hertz of the whole frame, okay? And we then we might read it from the camera, the entire frame. But once there is a detection, we're really following only that and taking only that piece to the CUDA, okay? So this creates like a lower frame size and a higher frame per second, right? And again, I'm speaking about only the all-sky camera. I'm not speaking about the PT right now, okay? PT will be a whole different creature in my mind. That's where the motor comes into place and live tracking. Really.
Why are you talking right now about scaling down the images from the camera? Why is it now a topic for you?
Because technically, if you detect something in the sky on a like an all sky, right, and you detect an object that you're interested in tracking, if that object is going to jump, such a large jump that the motor can't even follow, there's no reason to even track that, right? And you will not be able to. You will not be able to actually. Just a second. You will not be able to even fusion that. There will be some limitation of how. And I give an example. If you see like a pixel on the left side of the camera, and then that object moved to the right side of the camera, right? We will detect it as two separate objects, not as one. Even if physically, let's say it was a real one UAP. Okay, just an example. So I'm thinking like reducing that frame to something more reasonable. And we can play with it. We can
Why is it
test
reducing
it out.
the frame to something reasonable? Why?
Because it's processing horsepower. I mean, if
Yes,
you
of course, but
honestly,
you also
so
lose information.
yes, no, well, it's not, it's frame rate. So if you want to run, so it's a combination of stuff. So basically, and I can show you examples of this where, like, some of these new background subtractors take, on my little PC, take like 2 or 3 seconds per frame to run, and the frame is 800 by 600 pixels in size. So, and it's taking that amount of oomph, you know what I mean? So it's basically, if you, so all like from my side is, and this is just the challenges I've been having, is that in order for tracking to work, you need a high frame rate, because if you don't have a high frame rate, the object jots around. There's such a big distance between the object of interest that the whole tracking thing sees it as a different object.
Of course.
It doesn't.
Yes.
It doesn't make the determination that it's
true,
the same thing. So it's
let's say that we want to track ISS and we know it's a single pixel. Okay. Do you need the entire frame, 20 megapixel, 20 hertz a second, or you need the piece that is reasonable for an object that flies, I don't know, 100, 200,000 miles an hour, and I'm exaggerating in purpose, okay? And you can extrapolate that on what's the frame size or the reasonable frame size that you can now look on the second phase of the tracking. So we had detection, we recognize the ISS, now we want to start tracking it. We don't need the entire frame. We can still publish it. We can still record it to the recorder, okay? But what we actually send to the CUDA needs to be a subset of it. Doesn't need all of it. But again, this is optimization.
But there has to be a detection in the first place in order for you to reduce it down too. But again, you need the full frame anyways.
Yeah, but you don't need it 20 times a second.
Ah, okay.
It's not gonna.
Yes.
That's
no,
what
but
I mean.
I'm not. Yeah. So I don't. Yeah. I mean, so the only thing I can comment on are the challenges that I've experienced. And don't get me wrong, my setup's not perfect. I've got a camera attached to a garage and it's connected via RSTP. It's not a USB cam, and so it can be made quicker and all these sorts of things. But even if I, so it's a 4K camera, even if I could get, and the camera's able to produce a frame rate of 15 frames a second, if I could get that frame rate, I don't have, my computers just aren't powerful enough to process that size frame at that pace in order to track an object that's darting around. And I can show you examples of like insects that fly around it, and they move so quickly. And I know it's not a fisheye cam, it's just a normal security cam, but they cover such distance from one frame to the next that it doesn't see it as the same object, so I can't track it. It just thinks it's a different object. You know what I mean? So
yeah.
So what does that help in resizing?
That's where simulation is important. That's why recording the data is important. Okay. And this is not something you will be probably able to answer today, but 2 years from now, when we have enough data, right, we will be able to start tackling that much better. We will have think about it. Right now, we are trying to kind of break down the subsystem and define its input and outputs, and we don't even have that. But once we have that, then we can play around with that subsystem inside and simulate the input, ensuring the output, create the feedback loop for the AI, and really build that.
Yeah. Okay. No, that's fair enough. I'm just trying to I know it's very just like a very specific portion of the whole thing, but it is, and it's fine. Like it'll probably track a plane, because an airplane, because an airplane flies in a straight line, whereas an insect doesn't. It kind of bounces around all over the place. So and this is the difficulty. I don't know how a UFO is going to fly. I don't know if a UFO is going to go in a straight line. Is it going to behave like a plane, or is it going to behave like an insect, sort of thing? I don't. Who knows? So all I'm saying is I'm just finding like the hardware I have. All I can say is the hardware I have, and I was having a chat with a mate last night because I bought the PC from him, and we worked out that it's probably about a 9-year-old i7. So it's not a new PC. It's not a new CPU, but it's having a challenge trying to track a bug that's flying around, and and this was my comments about the CUDA stuff is like, if I were to run in OpenCV, there are a couple of background subtractors which can run on CUDA, okay? And if I run a CUDA background subtractor, I get double the frame rate that I do with a CPU-based background subtractor.
Really?
Okay.
Wow.
Yeah, but the background subtractor is not as good as the CPU background subtractor, so I get so many more false positives. So when it comes to a tracking point of view, and tracking only happens on CPU, not GPU, so when it comes to tracking, the frame rate drops from like 40 frames a second to basically 5 frames a second, whereas because it's trying to track objects that don't exist, whereas the CPU background subtractor does a better job in doing its job of background subtracting, so it has fewer false positives. So actually when I'm tracking stuff, my frame rate is better on a CPU pipeline than with a GPU pipeline included, because the background subtractor is worse. The CUDA background subtractor is terrible compared to the CPU one. Sorry, I hope did that make sense?
Yes. And what I'm trying to say, this is fine for now.
Yeah. So
okay, more than fine even.
Yeah. So there is a challenge there with I mean, accuracy, clearly from my point of view, accuracy has a big factor because it reduces false positives. And if it reduces false positives, there's less things to track, and tracking is the most expensive operation when processing a frame. So if we more accurately track stuff, it's better than tracking stuff that doesn't exist. So that's what makes the background subtractor bit so important in a way, because that gives us ultimately the blob that we're trying to track. So if that does a really good job, everything else is better. If that produces less false positives, everything in the else in the pipeline goes quicker because there's not more unnecessary work to do.
Don't worry the speed of the pipe right now.
Keep it simple, tracker.
Get better.
Yeah, I'll try and get some numbers on how long it takes, because there's some really groovy background subtractors here, and I'll try and get some numbers on how long it takes to process a 4K frame, and I'll get that back. I'll get that over to you.
Okay.
And because that'll just give an idea, as it's just information, right? It's just kind of helps with making decisions and stuff. I'm just also explaining the challenges that I've experienced and the things that I've seen, and again, I said this a lot in the past is my software is not perfect. It's not 100%. If anyone else can find any bugs, they're more than welcome to highlight them and help and all those sorts of things. So it's very likely that there is problems in the software as well. But from my point of view, those are the challenges I've been experiencing.
Do you know what nature the background subtraction is? What algorithm is used in both ways?
Yeah. Okay. So let me just get the names up here because I don't know them off the top of my. Just 2 minutes. So basically, So before using this new library, the CPU background subtraction algorithm that we used is KNN, and the GPU one is MOG2.
Okay.
And the only reason we don't have KNN GPU is because that just doesn't exist in the OpenCV world.
I was wondering if we could do the background subtraction right at the moment when the image is taken from the chip. So we have to do some bias correction, some dark current correction, and I do not know if we need a flat field correction, but we could use a flat field correction as a background subtraction. And this could speed up everything because it's done right within the camera.
I mean, if that's
the image you will get already is background subtracted.
But I would need more than that from an image standpoint, right? I couldn't just have the background subtraction image. I couldn't just have basically the foreground objects. I would need the whole image also because
you would get it at least in two data sets. One is the background, one is the background subtracted image. Like this. Have a look at Sextractor. It's a program from Emmanuel Bertin. He does that with a neural network, and he wrote it, I think, in 1992. And he does it very conveniently.
A neural network in 1992?
Yes, of course.
So what was that called?
Sextractor is the program.
Sextractor?
Yes. For source SEX. It's short for source extractor.
Is that something? Yeah, I suppose. Is that something that is usable by? Like, does it integrate with, for example, with OpenCV frames and Python, or is it just something on its own?
At that day, OpenCV wasn't on the market, but I think that we might use some of the ideas from that day. Source extractor is or Sextractor is already developed, I think, from a group from the Minor Planet Center by now. But it's already available, and in astronomy, it's used for star galaxy separation, where background deblending is one of the main sources. So you can, if you have an overcrowded star field and at least some hints of a background, you can do the deblending and the star galaxy separation. And this is done with a neural network. I think they use 2.7 million galaxies as training data, and it's very successful. But the background subtraction part I used 20 years ago for something else, because I took images from galaxy clusters and used this background subtraction information to rectify if there is a cluster or not, because you get higher values in the background where the galaxies are, and not where the surrounding part of the space is. So maybe we could use that as kind of, let's say, flat fielding.
Yeah,
And if
I mean,
both informations are provided, then this could be the speed up, because if we use segmentation, then we know where everything takes place.
But where is this
I
calculated
mean,
then?
yeah. So all I was going to say is the background subtractors in this other library, they're very good. Like, we live in an area where there's lots of clouds and all this sort of stuff. And there's one in particular that I'm using now, which is called I'll have to check that. I can't remember the name off the top of my head. Sorry, let me just quickly. It's called weighted moving variance, and it works better than KNN. I mean, I'll tell you that for sure, and it is actually quite quick as well. So that would be the one I would pick at the moment. I mean, I've tried to use some of the other ones, but they just take too long. So they do a really good job, but they just, it's just processing horsepower. It just takes time to process a frame, and if we can, that's what I was saying. If we can get to a point where we go, right, this background subtractor is the one that we want to use. It does the best job of the lot. And then we see if we can get someone to write it so that it takes advantage of CUDA, or maybe by then I've kind of experimented a little bit with it, but I mean, they certainly do a good job. Don't get me wrong.
Christian, where should that part of software run that you mentioned before?
The idea at the moment is that we take the Pi for collecting the images, and the Jetson Nano via ROS2 uses the service to do something on the image. If we do the segmentation right, we could pipe it to the CUDA cores of the Nano, and because it's just a view on it, it stays on the Pi. So if we could speed up with CUDA, maybe we are coming up with our own background subtraction, we can do it in combination with the Pi and the Nano. But that we have to write by our own.
Oh, wait a second. You have the camera, and on the camera is the Pi, and the Pi is the first entity that receives the data from the camera, right?
Yeah, and you have to do some data reduction at first. Bias subtraction, dark subtraction, flat fielding.
You're pre-processing, let's call it. Okay.
Yes.
But then you have on the Pi a full frame by frame. And you say you want to transfer that frame to the Nano in order to make the background subtraction for the Pi?
No, we do not have to transfer it. With ROS2, we do not have to transfer it.
But it is transferred. Although there is ROS, there is a UDP transmission.
Yeah, that's what has to be developed at the moment. How we are going to do it, we do not know yet, but we have got some ideas how we can do it. The problem is that we do not know what hardware we are going to use, which one is the best for the job, and we do not know yet how the algorithm has to be most efficient. So, since we do not know that this is our actually working place, we cannot say, okay, it's better this way or that way. But we have to strip down the data load because it's huge. One image is between 35.5 megabyte and 50 megabyte. We have to strip that down. Each frame.
But you say you strip that down, you want to strip that down on the Pi during your pre-processing.
We'll compress it, okay, like a lossless compression, okay? And then the tracker will take that and do whatever it wants and create another topic with whatever metadata we want there, right? Like the detection, tracking information, whatever.
Background image.
Yeah, background image, exactly as we saw last week, right? The overlay and all of that. Now, what's nice about it is that now, once we understand what's the performance of everything, we will know where the bottlenecks are. We will know, we can map it now to the kind of existing hardware that we have imagined, like the Pi and the Jetson. And now we can start mapping and breaking down what will run where and where we see bottlenecks that we can improve the performance on. Okay? Now, because it's all again, like in the end, like a function from an input and an output, it will be very, very easy to kind of see where the bottleneck is and how to improve, right?
Yes.
And that's where we are trying to get to. Okay? In theory, think about it this way: we can run multiple versions of the tracker in parallel. One that is CPU based, one that is NVIDIA based, one that is whatever, and kind of do comparison, right? Where we get better in parallel or switch from one to another, right? Because it's all based on topic, it's all based on subscription. That's the capabilities of both.
I get
right?
that. I get that. Yeah. So
Doesn't,
the system can be adjusted by just yeah.
Yeah.
Christopher.
Yeah, I mean, doesn't a 4K video already subtract the background? I mean, depending on what log
we
you're
do not
using,
have
it
4K
subtracts.
video. We do
Uses
not have 4K
videos.
video. We
no, that's
we
just
are
my
as raw. We are as raw as we can get. We get images from the camera, and we do not. We didn't want to go the route that we encrypt the video first, because this takes time, and then decrypt it and split it up into single frames again. So, and
So
one
like a
important thing
planetary
is,
astro camera running 90 frames per second.
yeah, but
Or
these
something
are
like that.
only 8-bit, and we have got 16
10.
bits.
6.
So it's all about resolution. Yes, between 256 shades of gray in each color channel, or you have got 65,536 shades of the same channel. It's a different, because then we've
Is it
got
necessary
resolution.
for tracking, you think?
Sometimes yes, because if you have got smearing, because the object is moving so fast, then you can measure the shades and calculate it back, and you get much more precision about it. So yes, it might be useful information, but we have to have hardware and software that is fast enough to do that.
Yeah, so think about it also in another way. The raw data is not going to change much, but the tracker algorithm is going to change a lot. We are going to improve a lot out of it once we have the bus kind of ready. Like again, the function from inputs to outputs.
Okay. Are you still talking, Ido?
No.
Okay, I didn't hear you anymore. Okay, yeah, so I'd say we're 2 minutes to the clock, and this is a big topic, and I think we have to talk again and again and again about it the next Sundays. And I hope you do not get tired, especially Ido and Christian, of my many questions, but I also think for all of us, for stationeers, and I think for Tommy, because he popped in right now, and that's why I think it is my purpose to stress those questions and, yeah, to push. All right, guys, I say thank you very much for your time today. I will now stop recording.